Come on, up it. Come on. Okay. In this episode, we're crate training our app by giving it a real database for its data to sleep in. Last time, we built some solid domain types, filled them with sample in-memory data, and exposed a few Axum endpoints to interact with that data, like fetching dogs or updating their weights. But in the real world, that data needs somewhere to live. So today, we're going to persist our data properly by hooking it up to a PostgreSQL database running in Docker and connecting to it with SQLx, one of Rust's most popular async DB libraries. So let's grab our cargo, crates, and containers and head down to the docks. Welcome to Byte Size. This is a new segment for my videos. I felt going back that I've dived in a bit too deep, too quick on the previous videos. Whilst these tutorials are aimed at people who already know about coding, I should probably spend a bit more time covering the trickier topics before diving in head first. So we'll start today by looking at memory management in Rust. So here we're looking at the old way. So with, this sort of C or C++ style of memory management, you're sort of, you're manually allocating the memory, you're doing something with it, you're manually freeing the memory, and then you get sort of, potential errors like this where you're accessing something that you've already freed. Maybe the content of that memory is as it originally was, or maybe, this is further down the line and something has changed it. So you've got all sorts of errors there. And then you've also got errors if you forget to free the memory. You've stopped using it, but the memory is still allocated. So that's called a memory leak. And, with a long running application, that can basically mean at some point it's going to just completely run out of process memory and crash. So that's one thing. Obviously in the sort of new world of garbage collected memory, then, things are obviously much better because you don't have to worry about that stuff, but also you're introducing a level of sort of non-determinism there because at some point that garbage collector has to take over and start moving memory around, freeing up space. And if you have an application that needs to be, where its performance is critical, then that can cause issues because suddenly the garbage collector kicks in and you've lost control. So that's that. Let's have a look at what we get with Rust. So firstly, with Rust, we have this concept of ownership. So a string gets created. It gets assigned to S, which now is the owner of that string. Only one reference to a string, only one reference to a block of memory is allowed at any one time. So when we have something like this, where we say let T equals S, this no longer means that, oh, hang on, now we've got two references to this string hello. No, what it means now is that now T is the owner of hello and S isn't the owner of anything. So therefore, if you were to do something like this, that's an error because S is no longer the owner. T is the owner now. So let's look at the concept of borrowing. This is basically where we need to give something else access to a block of memory that we have ownership of. Now, the rules for this are that you can allow multiple immutable borrows of that memory. So we know that various different functions can each make use of the memory, perhaps, but they're not modifying it. So we know for a fact then that sort of code is going to be thread safe because there's no way any of the different uses of it can be stepping on top of each other. If we want to take a mutable borrow that is allowed, but it's only allowed to be done once and not while we have any immutable borrows for that variable. So we can only have one mutable or multiple immutable borrows, but never two together. So let's see how that works here. So we've got this block of memory name that we have ownership of. And here we can see we take two immutable borrows from it, R1 and R2, and then they get used here. And that's the only place they get used. They don't get used later on in this method. So the compiler now knows that from this point on, R1 and R2 are done with. That's fine. So here we can then have an immutable borrow R3. R3 allows the original name to get mutated. And then that's the only place it gets used. And again, that's the point where R3 is no longer used and that borrow completes. The compiler can check that. Now looking at this is an example of something that you cannot do. As we did above, we take the two immutable borrows, but then we try and take a mutable borrow at the same time. We're looking to use all three of those later on, so they are still in scope, and therefore this will not be allowed. This is a compiler error. You cannot do that. So that's just a really brief introduction to borrowing. Obviously, you can see the benefits that gives us in terms of thread safety when we know that the only reference we have to something cannot be modifying the original memory. And that leads us on to, the important concept that you may have already picked up on, that we have automatic freeing of memory. So where we take ownership of something here, so where S becomes the owner of this string hi, that's where the memory gets allocated for it. And then as soon as we go through the code block here, S is used at this point, but it's not returned. It doesn't get sent anywhere else. So at this point, S goes out of scope and the memory for it is freed right there and then. So we don't have any of the worries of, when should S be freed? So that's just a brief taster on some of these topics for Rust. You can get a lot more detail if you go and have a look in the Rust book. That's a brilliant resource for this sort of stuff. And, concepts of borrowing and ownership and lifetimes can be surprisingly tricky. So take a look at the book if you really want to dive deep into how this stuff works. But now let's get on with today's coding. Okay. In this first session, we're going to look at installing a database for Rust, or more specifically, we're going to look and find out what the idiomatic database for Rust will be and what cargo module is our best choice for interacting with that. For this application, obviously, we want something fairly lightweight. It's not going to be a massive database. It's just for our personal use. So that's what the focus will be on. And also, we don't need some really complex ORM type thing for connecting to it. We want a fairly simple connection to the database from our Rust application. So what I'll do is I'll switch over to ChatGPT and ask it to do that research for us. What is the idiomatic way for lightweight database access in the Rust architecture? So asking in Rust, what is the idiomatic database and what's the idiomatic database stack or cargo module for the database interaction? Didn't really tell us the database. So then what? Okay, so Postgres SQL for the database. And it looks like SQLx is the option for database connections. As soon as there's this diesel option, but it's saying here that it's a steep learning curve and it doesn't support async, which is not necessarily great for us. We don't really want to go into ORMs so much. So yeah, I think we'll try SQLx. Okay, just following the documentation here on how to get a Postgres instance running in Docker. So we'll follow the instructions here saying to pull a particular version and then to run that as a local Docker image. So if I drop in here, I can say Docker pull, it's Postgres 14.5. And then we just want to run that up. Docker run name doggy post, just doggy db a postgres password equals Captain Scrunch. And there we go. That's Postgres running. So let's take a look through the docs for SQLx now and see what it is and what it can do for us. So truly async, compile time check queries, database agnostic, but it supports Postgres, of course. Pure Rust. So 0 unsafe code. So for installation, it supports these runtimes. Oh wow, a lot of choices to make here. Async, stood, took.io, no TLS. So no. Oh, okay, so that one is with no TLS and that's with native TLS. I mean, we aren't really worried about the transport layer security at the moment for this demonstration, so I think we can just go with that first one. I think in the previous episodes, we've kind of gone with the defaults for these things and without maybe necessarily understanding what some of this stuff is. So I want to find out what this toc.io library or framework is. So let's go and ask ChatGPT to do the research and give us a TLDR for that. Okay, great. That really clears things up. I probably should have researched that a little bit earlier, but yeah, so it's basically the mechanism for allowing asynchronous running within the main function of a Rust application. So effectively giving some sort of equivalent of like the event loop that we see with, as it says, Node.js, but also like Windows, etc., is based on that. So it does that and handle the scheduling, running, and async IO, and I guess doing the sort of IO completion type stuff where we kick off a sort of long-running IO operation, like a disk operation, and it means that rather than sitting there spinning the CPU waiting for a result to happen, it can just have and install a handler that gets called at the point when that IO function completes, and therefore that picks up the thread and carries on. And I guess that's probably what it's doing for us here. So yeah, that's useful. Let's move on back into looking at SQLx is what we're looking at. So yeah, I guess we can say what we really need is just this first one for the moment. So let's copy that. And we can drop that into our cargo.toml. So here we are. Let's drop in SQLx version 0.8 and runtime tuckio. Save that. It seems happy with it. Let's just try a cargo build to bring across everything we need for that. Okay, there we go. So that's SQLx installed. It seems happy with that. So let's go back to the docs and see what we can do just to exercise the connection with that database to make sure we're all set up. And that's all we need to do for this first session. Just make sure, our database is installed. It's running there in Docker. We've got SQLx installed. That's running as part of our application. And that SQLx can talk to Postgres within our Docker, within our running Docker container. So let's take a look at doing that. Okay, here we go, usage. Okay, so it's saying here that the preferred connection is to use a connection pool, which is established at the start of the application. And then once that's done, you can then just use direct queries, which will pick a connection from the pool and obviously limit the number of simultaneous connections that you can have. I think that's probably going to be fine for us. This is only a lightweight application after all. So we can go with that option and with the default of, maximum 5 simultaneous connections. So I think what we'll do to start off with, just to make sure this is working, is we'll go into our main method and pretty much comment out what's in there already, and then bring in what we have here for this example. And then we can use that to just double check that we are able to connect from our Rust application to the Postgres database in its Docker container. Now this should be tuckio. Result import Postgres and SQLx. We're missing a
cargo report for that. Do I need to say features Postgres or something? I'm making it up as I go along. This is probably not going to work, but let's see what happens there. Oh, that was a good guess, wasn't it? So, okay, so I brought in Postgres as a feature. A connection pooling here. Password was kept in Scrunch. It's localhost and it was DoggyDB. I'm hoping that will work. It probably won't. We'll probably have to go and find the right connection string for us to be able to use to connect into that Docker container. But anyway, query as select $1. Don't know what this bind does. Let's see if that works. Pool timed out. Okay, so that probably means we didn't connect to that successfully. Let's just ask ChatGPT about the connection string. Right, of course, because the DoggyDB is just the name of my container, wasn't it? So that was a bit dumb. So Postgres kept in Scrunch, localhost 5432/Postgres. So Postgres kept in Scrunch. Yeah. That looks fine. Let's give that a try. Nope. Okay. Yeah. That's what I was thinking. I didn't specifically expose any ports from the Docker container. So we could try this to start off with to see if it's automatically exposed any ports. Docker port DoggyDB. No, it hasn't. So we need to get rid of it then. Docker RM. You cannot remove a running. Okay. Docker kill. And then just do what he said there. Docker run, DoggyDB, kept in Scrunch, and adding in the port mappings that we missed out last time. Okay. And now if we do that Docker port command again. Excellent. So 5432. 5432 is what we had there. So let's try it one more time with that. And that looks like success to me. We did an assert there and it did not blow up on that assertion. So good. That's the first step done. We've got our database installed, seems to be working. We've set up our database connection library within the Rust application. So next up, we need to look at actually, populating that database with some sample data. We need to take the the sample data that we were playing with previously in the previous episode and actually use that as day one data to insert into the database. And obviously we need to make sure we've got the schema for the database. So we've got a table for the dogs. We've got a table for the feedings and whatever else we needed to do for that. So we'll get onto that in the next section. But for now, let's go and take a look at the whiteboard.
Okay, so good right, sit there, sit there, get there. Okay, so as we know, today we're going to do database integration. Mr. T, are you going to see? So we want to have our database here. What do you think? Hey, Captain Scrunch, Mr. T. So we've got our database here, and then we need to get some tables into the database. So we do our first migration to the tables. Okay, Mr. T, Mr. T, hey, come here, come and sit, come and sit. There we go, that's better, look, see, and then we get the data that we want to go, gets put into the database as well. And then finally, for our service, it's going to get all its data from the database, and that's what it gets served. Okay, well, you're not particularly interested, so let's just get on with it. Captain Scrunch, what was that all about, huh? What was that all about? What was that all about? You like the Wookiees? But Daddy's got some coding to do, okay? So we're going to have to get back home.
Right. In this session, what we need to do is to set up our database migrations. So we've got our database created. We've confirmed that SQLx works for us. So the next step is to make sure that we can get our database schema in place, the tables that we require and the references between the tables. And then we need to look at inserting our day one data. So that's the dog sample data that we had before into those tables, so that we're then ready to present the API from that database. Let's take a look at setting up the migrations first. To do this, I think there's a couple of tools I need to install, so I'll just walk you through that process and then we'll get on to the migrations themselves. So firstly, I've heard of this Beekeeper Studio application, which is supposedly a sort of modern and lightweight database schema and content browser type of thing. So let's get that installed, and then we can take a look at what's inside our Postgres database container, which means that later on we can confirm that our migrations are doing what they're supposed to be doing. So let's take a look at that. Yes, please. Okay, some part of it failed, but looks like hopefully it got around that, maybe. Okay, so it does run. Let's take a look here. We want to say Postgres, please. We are using username and password, host and port, localhost 5432, I believe is correct. User is just Postgres, I think. Password was Captain Scrunch. We don't worry about default database. Let's just test that connection and connect. Select a database. Okay, it's just called Postgres. This just gives us a demonstration of a query that we can make against it. We don't need to worry about that, but obviously we know there's nothing here at the moment. So we'll get onto that shortly. Let's just minimize that for a second. Okay, next up, we're going to install this SQLx CLI tool, which, amongst other things, allows us to automatically create a migrations or a version migrations folder within our source code. And then that sets up the capability within the startup of our application that we can tell it to check for any pending migrations and to automatically apply those before we then go into the main app. So let's get this one installed. I can see here it's saying cargo install, no default features, native TLS and Postgres. So basically it's saying we don't want it to support all databases. We just want it to support Postgres with native TLS. I'm not sure if we need the native TLS because we didn't install TLS previously, but let's just give that a try anyway. So here we are back in our project. Let us try doing that install. Okay, cool. That's completed. So we've got our database browser app installed. We've got our SQLx command line tools installed. So the next step is to actually go ahead and use SQLx CLI to create the migrations we need, and then to go in and add the tables that we want to create for our simple, our current simple database. Oh, so it's not SQLx CLI, so the command it installs is just SQLx. That's good. Okay, no worries. So next step is we need to create a .env file, which just allows the command line tool to find our database without us having to type in connection string password all the time. I believe, because ChatGPT just told me, it should be database URL equals, and then we can just put in what we had there in the program. Save that down. And then here we can say SQLx database create. It probably won't work because that database already exists, but let's see. It doesn't complain anyway. So looking here at the SQLx command line documentation. So again, we've done that step. We've created the .env file, we've checked that. So we need to now add a named migration for our first migration. We can just call that first. So SQLx migrate add first. Migrate add first. And there we go. So that has created migrations. And then in there, it's dropped in a SQL file for that first migration. So all we need to do now is to create the tables that we want. What I'll do in order to simplify this process is I'll copy across our struct there into that script. Where's it gone? Like so. And then the same for feeding. Wherever it is. And then we can use this as a basis to actually create table commands that we're going to drop in here very shortly. Okay, I found this little starter guide to DDL within PostgreSQL. And that seems to give us what we need. It doesn't look particularly different to SQL variants that I've used before, but we can see how to do a create table there. Let's just copy that across. So create table, that's going to be dogs to be consistent with the way SQL does things. And then our name, we can use varchar 100, why not? $100 and not null. Same for the breed. Hello. Right, that's that. Date of birth is a date. Also not null. Weight, I think there's a real type. See how that works. Not null. Feedings, we don't need to do that from here. Now we need to do some constraints here. We're going to say that dogs. Why is it not selecting when I do this? Dogs, P key, primary key over name. And because of that, we need to also make sure that name is unique. That sounds about right. Okay, that's cool. So feeding. So we'll need to give feeding its own ID type, ID to act as a primary key. Table feedings. Like so. Time. Do we have the concept of time? Let's try it. Just worried about things like that. Are going to cause us trouble. So just want to see if we can we get away with doing that? Just do it for everything, just to be consistent. It's not no. For the moment, let's keep food type as a string. Or a varchar, I should say. I'm not sure what we need to do to deal about the fact that it's an enum type, but let's circle back to that later. And mount grams is an integer. Not null. As I said, we wanted to create an ID for this as a primary key. That's a serial, which I guess means it creates the values automatically for you. Not null there. And then you can add that constraint to represent the primary key. Make sure it's named correctly. Like so. And then finally, we need to have a foreign key constraint to reference, to say that this is reference to a particular dog. Create index. Let's not worry about indexes for the moment. Let us add constraint consultants. Let's just try that. Constraint dogs feedings. Name foreign key dog. It's done it again. Dog name references dogs name. Sounds right, doesn't it? Okay, let us get rid of that. So potentially that's all of our SQL done. I'm sure there might be some problems with this. We'll be coming back to that in a second. So now we need to go back to our main function and modify that so that it can automatically apply the migrations at the start. And also we'll take this opportunity to update the original main function, which we commented out previously. We don't need to do that anymore because we're now going to start using this database for real. So what we can do is if we bring them up side by side, give us a bit of space, like so. Uncomment everything that we've got there. Now we will need to bring across our SQLx stuff. We've got Taco main, and we change main to say it's returning this result of either unit or some sort of SQL error. This set of dogs we will be getting rid of in a minute once we can do the day one data upload, but we haven't got to that bit yet. In fact, before we do that, let's do all of the SQLx stuff up here. I wonder if it can get this from... Okay, I'm reliably informed we need to do this. So, loading environments from .env file and then specifically extracting a variable that we need from that and obviously blowing up if that doesn't exist. And then here we are saying database URL. Awesome. Okay, so next step is after doing this, we then need to apply our migrations. So I'm seeing that when we're installing this in our Cargo TOML, it's expecting we're probably going to need these additional features to be included, the macros and migrate, which we will be using right now. So let's just get rid of the previous one and save it down with that one. Make sure it is happy with it, which it appears to be. And then back over here, we can say SQLx migrations. So migrate macro, run against our pool, and await. So that should therefore apply the migrations that we need. This is not showing any errors, and I think that's because it's still got this funny name. So let's close that one down. We'll delete main.rs we created there. Yes. We'll rename that. Main.rs. And now we find all the issues. So that's fine. I'm sure we need to bring in some, no. Generate.env function. Okay. Yeah. Okay. Right. That's a bit of a rabbit hole. We're not going to go down any further. So let's go back here and we will just delete that stuff. And we'll connect directly using our connection string. Okay, this sounds wrong. That's weird because that worked previously. It's async function main. It shows it returns result. Is it just the fact that we don't return anything? Yeah, it might be down to this. Right, okay, so it's just the inference which is causing us problems there. We needed to just make sure that we return that OK unit result at the end if there's no other problems. Okay, that's cool. So theoretically, that should now work and it should apply our migrations. And if it gets to the point where the listener starts, then we are good. So let's do a cargo run on that and firmly cross our fingers. I think we will have an issue because I suspect the SQL is not correct. Yep. Okay, so it doesn't like the way we escape the name character. Okay, it's double quotes. So let's try that again. This time, dog name referenced in, okay, so we need to make sure that name exists here. It has the same constraints as this one, or same properties as this one. And that is dog underscore name, dog underscore name. Save like so. Try that. And I think that means that we are running. What we can do now is if we go back to our Beekeeper Studio, we do a refresh, we can see our public dogs and feedings. Okay, that's cool. So that's got us to the next stage. We've got our database created, the schema is being pushed there via the migrations. So next up, we need to insert our day one data into this. Now we could do that in the code, or we could potentially do it via another migration, which just has insert statements. I think I'll probably take that second option. So let's take a look at that. Okay, so that gives us our second SQL file. Put that side by side with the first one. So we are saying, setting the dog's name, breed, date of birth, and weight, values, T-dog and CS-dog, those dates, and that's fine. Into feedings. Yeah. That's dog name we used for that. Dog name. Time. We don't need to do it that way. We can just do it like so. T-dog, comma. So inserting values, doing it like so. Comma. Typing today is not my best. 4 of those. Semicolon at the end. Let's get rid of those. And this dog is the same for everything else. It's just the name that changes. CS. Oops, CS dog. Like so. That should do us. And then if we do the cargo run, waits a little while. Hopefully that's done it. Where am I looking? Big Cube Studio. There we go. No data. No data. So it didn't seem like it recognized the new files, and it seemed like it built anything there, so definitely saved that. Let's just do a cargo build. Whoa, hello? Where am I? Let's do a cargo build here. Cargo run. Let's hit refresh. Oh, there we go. Cool. So CDog and TDog. And we've got all of the feedings there that relate to the various dogs. So that's great. Our data migrations are working. We've got our day one data into the database. So in the next session, what we can now do is basically take that data and expose it using our API, so we can get rid of the sample data, the in-memory sample data stuff that we were using before. But now I think it's time to pause for coffee. Obviously, Rust is a hobby project for me. My day job, that's C#, Angular, and Azure, and I'm pretty comfy in that world. I've shipped production apps, wrestled with deployment pipelines, and danced with cloud resources more times than I can count. But here's the thing. Even when you're solid across the full stack, you're never flawless in every layer. I don't know all the quirks of CSS across browsers. I couldn't map the nodes modules directory without a compass and a trail of treats. And sometimes, as is resource graph, still feels like one of those puzzle toys made for really clever dogs. But that doesn't mean I'm not full stack. It just means I'm fully rational. The truth is, modern development is wide and deep and weird in places. You can't be a guru in every corner, or is it layer? You just need curiosity, good instincts, and the ability to learn what you need when you need it. That's why I love playing with Rust on the side. It challenges me to think differently, to slow down, and to see things with fresh eyes. And it's fun, especially when dogs are involved. So if you can't work out why your text box is 1 pixel lower in Safari, or why your VNet can't access your PEP, don't let the imposter anxiety creep in. Remember all the stuff you're good at, and don't be worried about asking for help. As always, please like, comment, subscribe. It's still early days for me, and I appreciate any feedback. So, in this final session, what we need to do now is to replace our in-memory sample data with data coming from the actual database. So the first thing I need to do that is to make a little change to the food type enum, just so that SQLx knows what it is and knows how to convert to that from a string when we do our SQLx query. So let's go into the code and start with that. I know. Here he is. Here he is. Mr. T. You come to watch, have you? Come to watch. Good stuff. Okay. I know. Okay. It's not too helpful. It's not too helpful, little guy. Okay. So, do you know how to modify an enum type so that SQLx knows what to do with it? Who's that? That's you in the mirror. That's the mirror I use to make sure the camera's recording. Huh? And that's you. You're in there. Come on, off you get. Okay, so here in our feeding.rs, we've got the food type. Obviously, it's got the usual stuff, clone, serialize, deserialize, but we need to add some SQLx specifics to the top of this. So basically, it shows what the name of the type in the database is. So if we look at our SQL, we've got that food type. And then this rename all, just so that, if it comes up as lowercase in the database, it will correctly deserialize it. So we need to add a reference to SQLx. What? Just use SQLx, right? Okay. That took a lot of messing around to work out what was going on there. So yeah, it seemed to be the fact that we were missing this type on the derive. So we need the SQLx type here and then that type defined, and then it understands what this is. Okay, that's fine. Now let's take a look at updating the main method to, instead of passing in the static data to all of the handler functions, it now needs to pass in the connection pool for the database so that each of the handler functions knows how to access the database and execute queries against it. So let's bash out some code. All right, back in our main method here, we can get rid of our vec of dogs. That's gone. We've got that sample data in the database ready to use. Our connection pool gets created there. We run our migrations. We don't need shared dogs anymore. That's gone as well. Everything's ripping out here. So the final thing we need to do is we need to pass in a clone of our pool as this extension that gets passed to each of the handler methods. And then that ought to do us. Okay, it seems happy with that. So let's go and have a look at the handlers. We're going to need to rip all of these apart. So this is now taking a pool, which is an extension of PG pool. Let's bring in that import. Let's just take that out for a second. Okay, so it's worried about the return type, but it's not worried about this, which is great. So let's copy that pattern for the other handler functions. Like so. And now we can actually crack on with getting some actual SQL in here. So let's start with let dogs equal, and now we go via SQLx query as macro. Okay, now we want to tell it what type we want. So we want it to be the dog. And our SQL is simply select star from, and is it dog or dogs? Dogs. So that gives us that. And now we want to tell it to fetch against the pool that we have. What's this? Just trying to connect to the database whilst I'm doing this. Really? Didn't actually have the database running, so let's just spin that up. Everything should be there. Make sure our database is started and running. Okay. Dot await. Dot unwrap. So that gives us dogs. Okay, so we're going to return not JSON of dogs, which should be a vec. Yep, don't need to do anything. Don't need the semicolon. Let's just save it like so. Okay, so this is just going to complain that it's missing the field. It's missing that obviously because we have a one-to-many relationship in the database. So we're not fetching anything in through that relationship at the moment, and therefore this feeding's
vet within dog is not populated. I'm going to come back to trying to bring in data from the feedings table and joining it in with this, but let's initially just take a look at how to leave that empty, just so we can get these initial queries working, and then we can look at building them out to be more complicated. Okay, so I've done a bit of head scratching, and I have needed to make a couple of changes here. So I've taken this back into a consistent format where all of these methods are returning the into response implementation, which enables us to do things like this. You know, we can define the status code we want, payload for the status code, and tell it to come up with a generic response for that without us getting into issues with consistency of return types across different parts within each of these methods. So that's one thing. The other thing is that I needed to change the feed type in the database into a database enum type and then modify the table to do that. So in order to do that, I've added a third migration, which is this. So we can see a database enum type of food type, which has the various values that we allow, and then obviously changing the column of the feedings table to use that food type, and obviously relying on the fact that our string matches these values. So it'll just convert that across as expected, and indeed it did. I've confirmed that by just going in with Beekeeper Studio. Hello, Mr. T. You're here to assist, are you? That's always useful. That's always useful. I know, the ball comes up. Yep, okay. Oh, careful. Careful, little guy. So that's that part. The other part is the fact that we cannot just create a instance of dog that doesn't have the feedings populated. So our options are, we either modify the domain type to make the feedings optional. I don't want our domain types to have to implement features that are pushed onto us by the database layer. So instead, what we need to do is to create a type here specifically for the database interaction. And what we need to do is to do a select across dogs and feedings, which joins the two together. So for each dog, we'll get the multiple feedings as an inner join. And then we can define a denormalized type, which gets each of those rows, and then use that to build up the dog with the feedings. So let's get on to doing the SQL for that first. Well, actually, in fact, let's create this type first, and then we can do the SQL that will deserialize into that type. So yeah, I've taken a look at this already. So we've basically got the two parts of this. We've got the name and breed, date of birth, and weight that we are taking from the dog itself. And then we've got the time and the food type and the amount grams, which we are bringing in from the feedings table. Because of the way the join works, these need to be done as options. That's fine. We will make sure that for each row that we take, that these all have values. Otherwise, it's considered to be invalid. Okay, right. Next up, let's go into get dog by name, go into the implementation of this, and we'll do the SQL query that we need to extract those join tables into this denormalized type. So, okay, this here is the SQL that we need. You can see it is deserializing into that specific type we created. And it is selecting the things that we saw from the dogs joined with feedings on the names matching up. And then we're passing in one SQL query parameter into this, which is going to be the name of the dog. So let's
bash out some code for that. So dot fetch all. Sorry, first we need to bind that parameter that we passed in, and we'll do that by passing in a borrow against name. And then we can do a fetch all, passing in our pool. And then we can await that. So that gives us our rows as being a result of a list of those rows or an error. So next step, we need to deal with that. So let's go and put in a match statement, which will just directly say, we can set, so let dogs equal match. So let dogs equal match rows. And it's an OK of a row. We just return that row. If it's an error of some sort of error type, then we'll deal with that in some way. And that gives us our dogs. So, yep. Now we need with this, we'll be short-circuiting return out of this whole method if we get the error here. So we can just return, and it will be a status code server error. So is that available? Internal server error. And then we want to create some JSON for this. So I've just cribbed this from ChatGPT. It's JSON type we recognized before, but we've got this JSON macro, which seems to allow us to do like an arbitrary block of JSON without having to require specific types for it. So we can say this error, and it gives us the error that comes in toString against that. So that's good. We don't need the comma there, but we now would need to say it's to into response, just into response like that. Is that happy? Well, it's not happy because we don't return anything, but I think the fact that it hasn't highlighted anything specific means that we're all right there. So tell you what, let's just have like a JSON, I keep saying actual JSON of unit into response. No, didn't like that. Okay, doing the same thing again. There we go. All right, so that's brilliant. So dogs is created, and then the next thing we want to do is obviously if dogs is empty, then we didn't match anything, and therefore it's a 404. So let's do that. Dogs.length. Is there a length? Count. I think there's an is. Okay, yeah, is empty. Then we return status code not found. JSON dot into response. Okay. Sorry, that's my C# coming into play. So it says we don't need that. So let's get rid of it. And it's happy. So we've now got our dogs list. But what we want to do is say, we now need to start creating the actual dog, the domain type dog that we need to return. And the easiest way to do that is we can take the first record in this response and get, the dog name and all of that stuff from that to build up the dog record. But let's make that record mutable, and then we can iterate through the set of denormalized dogs and create a feeding for each of those, which we can then push to the mutable dog. And then finally, we can return that dog as JSON. So it seems a bit convoluted, but it's fine. Mr. T, you're back again. You're a good boy, aren't you? Okay. Yes, you are. You're such a good boy. Let mute dog equal. Is it new dog? Dog new? Just dog? Dog. Not dog. Dog. With name. Name colon. Name equals. Right, name colon. Dogs 0 dot name. Breed. Date of birth. And weight. And then finally feedings. So vec of empty array to start with. Does that make sense? So to be clear about what I'm doing here, because of the way this join works, we are going to get multiple rows for the same dog. They're all the same dog because we are using this where clause here. And therefore, when we want to get the details of the dog itself, we can just get it from the first record. We can get it from any record, but we may as well take it from the first one. And then now that we've done that, we can now iterate over all of the dogs. And for each one of those, we can do the same thing to get the feedings parts and then push new feeding each time into this dog, which we then get returned. In fact, we can actually change that now to return the dog itself. And of course, this would work if we tried it, but would mean that there are no feedings. Should we just do that? Should we just give it a try? Guess we need to clone. Because we can't move from one to the other. So we should be able to just run that up. Let's do a cargo. Cargo run. My God, I can't type anything. And if we were to go into localhost rest and send that request, yeah, we get it. So that's nice. Obviously, as I said, the feedings are empty, but we've actually, first time, we've gone to the database, we got some data back. Brilliant. Okay, now let's get the feedings as well. We're almost there, so we may as well just finish off this last little bit. And then we can look at how we do the other parts of this. They're going to be very much similar, but obviously slightly different. If that helps at all. I'm rambling. So for dog. Okay. So sorry, this is just me being pedantic. These are still rows. These aren't dogs because these are these funny rows that we've got above. So we can do it like this. Rows exists, but now we're going to shadow it with this new thing called rows, which is what we get back from this block. We need to check here if rows is empty, and then, okay, so we can now go for row in rows. And you can see it's a dog feeding row, which is fine. And what we now need to do is say we need to make sure that each value within row does actually have a value. Because if you remember up here, these are all options, but obviously if this is matched within the join, then those should all have values. There shouldn't be some that don't have values, but we'll do belt and braces. We'll make sure that we only proceed if every single one of those has a value, and we'll use destructuring style to extract the values for each of those. So let's take a look at doing that. So we can be quite clever here. We can say if let some what are the fields we need? Time, food type, and amount grams. So some time, comma, some food type, comma, some amount grams equals row dot. Okay, sorry, we need to destructure those as tuples, of course. So let's say make that into a tuple, and then let's start a new line here, and we can say row dot time, comma, row dot food type, comma, row dot amount grams. So great. So just to be clear on this, in case you're not getting what's happening here, this if is kind of working like a branch for a match statement. And we're basically saying if we can declare this tuple, which has some time, some food type, some amount grams, against this. So basically it means that this will only match to true if all of these match these relevant ones. So basically all of them have a value. So if that's the case, then the if statement resolves to true. And not only that, we get time, food type, and amount grams available as local variables within this code block. So that's brilliant. It makes the code quite straightforward. And it means we can now say dog dot feedings dot push a feeding which has time. Now this works the same way as like JavaScript and TypeScript. If the property you're passing in has the same name as the property you're trying to set, you don't need to do like time equals time, food type equals food type. You can just do time, food type, amount grams, and that is fine. Okay, it expects a U16 for amount grams, so let's fix that. Should be easy enough to do. U16, I think we can just fix it there. Just tidy that up for the case of my OCD. And then basically what we've done, we've gone through each of those additional rows, extracted the data for the feedings, pushed that into the feedings list on the dog. And we're already returning that dog. So theoretically, if we save that and run it again, it will fail. Okay. I'm guessing this is because of the... Is it just because of the U16 thing? That's the only thing we've changed here. So let's change that back. 32. And just so we're not messing around, let's just change it here. Really, I should find out what's going on there, but I just want a quick result here, so let's just do that. Back into handlers. That should now be happy. It is happy. So I shouldn't be able to kick that off again. Oh, come on. Okay, it's broken that line of code. Well, that really wasn't as simple as I hoped it would be, was it? Right, okay, there we go. That was simple. So let's run that up and send that request. And there we go. So T-Dog, and we've got the feedings, the 9 a.m., the 1 p.m. treat, the 4:30 kibble, and the 8 p.m. treat. Brilliant. That's good. So that's the first of our endpoints now working completely with the database. Let's just get the other two done. So for starters here, we want to do kind of the same thing. We're getting the rows, but we are not restricting the rows anymore. I think that means we remove that because we don't have a parameter going in. We don't need to bind anything. There's no name there at all. And that will get us the whole set of dogs. So the difference here is obviously there are going to be multiple dogs in here. So we need to effectively do a group by on the dog name. And I need to work out how to do that in Rust. So anyway, there we go. That's the set of dogs selected. In fact, sorry, yeah, we want to bring in that other part as well, don't we? So we want to get the whole set of rows. We don't need to do the not found thing here. If there aren't any, then the result set is just an empty list. But we do need to do this. spiffing. Okay, so that gives us our rows, and now we need to do the group by. All right, so I am reliably informed that we are sort of a bit on our own for doing the group by. So what we need to do actually is to create a hash map which will collect or collate the set of dogs in memory. And then as we get each row, we can say, if it doesn't exist in the hash map, then we push it to initially. And then obviously for each row, like we did before, we're then pushing the feedings into the entry as well. So let's have a look at that. Let's create the hash map first. So hash map of string to dog, string being the name of the dog, in other words, the primary key. And then just as we did before, we want to iterate across the rows like that, but will be slightly different. We'll get back to that in a sec. So obviously here we don't have dog. What we need to do is to get dog. And in order to do that, we will use a feature for, there's a feature for fetching an instance from the hash map if it exists, or if it doesn't exist, you pass in a closure which tells it how to create that first one. So let's do that. So we can say let dog equal dog map dot entry. Dog name? Dog map, I said. Dog map dot entry. Which is row dot name dot clone. So that would be all we would need to do if we were actually just going to look up the entry. But we can say or insert with, okay, or insert with a closure, which is the double bang, if I can find that on my keyboard. And obviously that's a dog that we want to create. And we use similar creation logic that we used here. But of course we don't need to do rows. Okay, it gets a mutable reference out of that, which is great. So save that down. That looks like it's working. So for each row, we're getting our dog. Initially, the feedings is empty, but of course, each time we do this, we are then pushing new feeding into that dog. So at this point, our hash map has all of our dogs in it once we exit from here. So we now just need to basically convert that set of dogs within the hash map into a vector of dog. And I don't know how to do that. I will have to ask my helper how to do that one. Okay, so we have let dogs, which is a vec of dog, is dog map into values dot collect. So I guess it returns this returns an iterator, which we could go over like that, but we're just saying we want everything together and converting into a vector. And therefore we can then return status code dogs into response, and it didn't like that because we want JSON of dogs. Which is great. Can we run it? Nope. Of course not. Okay, so so this is, we're just basically discarding that first part, which is to do with, I think, the input parameters of the query, but we don't have any for this one. So we can just leave it like that, and hopefully that will be all that's required. Great. Okay. So let's go and see if we can get all dogs. And that looks promising. CS dog is there. Weight is there. Feedings is there. T-dog is there. T-dog's weight. Okay. Awesome. We are very, very close to finishing with this one. So let's just get that final endpoint done and we are complete. Okay, for our last endpoint then, we're going to be we are going to be executing SQL, but we are merely executing it. We are not bringing a result set down. So it's slightly different to what we've done before. But let's start off with just copying this block and we'll just modify it as we require it. So back in here. So our SQL is going to be something like update dogs, set weight equals, is it like $1, where name equals $2 or something like that. That's how I would imagine it. So we're updating whichever dog, whose name we get passed in, and that update is to set the weight to a particular value. Okay, so what we need to do is to update this to, it's not query as, it's just the query macro. Like so. And the macro takes the SQL and then each parameter that you pass in. So our first parameter was our payload dot weight. And our second parameter was our name. We don't need to bind the name. We're not fetching, we are executing. So if we save that, let's take a look at what that means. Okay, that's fine. So the result is a page query result or an error. So what that means, I think, is that the page query result is going to tell you how many rows are affected. So if rows affected is 0, then it's not found. We didn't find the dog for which the weight needed to be updated. If it's non-zero, then we've got success. It was updated correctly. And obviously this is a result. So if it returns an error, then we've got an error that's like an internal server error, and we can do the same thing that we did before. So let's go up and copy similar code to what we had before where we are matching the result with OK and error. But obviously, what we need to do here is slightly different for this, but that's fine. We don't need to say let rows equal. We are just doing this in an imperative manner. So if it is an OK, and then let's just call that OK over, let's match result, of course. Just call that QR query result. We can now say if QR dot rows affected equals 0, then return status code not found. Let's just copy the same thing we did up there. Else we return status code no content. No content is a success status code, but it just means that we're not returning anything. Can we just do that, or is that going to error us? Probably will be an error. Sorry. The standard mistake. But we don't need to do returns here, do we? We just need to say, if this is the last line, then it is a statement. So we can turn these into statements as well. Like so. And in the error case, we're doing an internal server error, and that gets returned as a statement also. So we are updating T-Dog's weight to 41. If we look at T-Dog at the moment, his weight is 38. Let us send that request. Comes back as a 200 OK, interestingly, even though I said no content. But if I now send the request here, comes back as 41. Whoa, there we go. So that's it. We've updated all of our endpoints now to make use of the database. We don't have any in-memory data anymore. This is all going to and coming from the database. So I think that's enough for today. Let's go and see what the dogs think about this.
Mr. T, can you... Hey, this way, Mr. T, see.
look, here's our application running now, and do you see what's changed? You're looking the wrong way. It's here. It's a T. Yeah. Do you see what's changed? See, now we have a database. It's not just in-memory data anymore. It's all sitting there in the database, look. And you prefer to have like a proper Postgres database, don't you? You don't like NoSQL. This is all in Postgres. It's running in Docker. Are you quite impressed by that? Not so much. Oh. Right, see. Oh, hey, Captain Scrunch. Alright, so you brought me for the demonstration. That's good. So, okay, yeah, alright. Okay, so can you see what's happened there? You see the new database? Next time, I promise next time we'll try and get a user interface for it. Is that good? I know you prefer that. Okay, that's about as much as we're going to get from them now, I think. So let's go back and summarise what we've achieved today. And there we go. Our app now has a real home for its data, not just a Jenga pile of Arc, of Mutex, of Vec, of Dog. We've set up Postgres in Docker, wired it up with SQLx, created migrations, and even added day one data. That's a pretty solid upgrade. From manky dog bed to swanky dog mansion. Next time, we'll take this backend and package it up properly using Docker Compose, including the database and maybe even the bare bones of a UI, so we can run the full stack as a single deployable unit. Whoa! Thanks for coding along with me. If you enjoyed this episode, don't forget to like, subscribe, or toss a virtual treat in the comments. It keeps these guys' tails wagging. And, as always, thanks for watching.
Captain Scrunch. Well, that must be really exciting, huh?